Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Tutorial, Part 12. In this video we will discuss about data frame in details with Part 1. In the previous video we discussed Pandas series in details. Similarly we will discuss about data frame. So in this part we will discuss all these 12 things. So let's get started without further delay. Alright, first of all we will introduce something about data frame. The data frame is a tabular data structure very similar to the spreadsheet. The most familiar are Excel spreadsheets. This data structure is designed to extend the case of the series to multiple dimensions. In fact, the data frame consists of an ordered collection of columns, each of which can contain a value of different type, numeric, string, boolean, etc. As you can see here, this is a data frame structure. Here we have columns and rows similar like data table. Unlike series, which had an index array containing labels associated with each element, in the case of the data frame, there are two index arrays. The first, associated with the lines, has very similar functions to the index array in series. In fact, each label is associated with all the values in the row. The second array instead contains a series of labels, each associated with a particular column. A data frame may also be understood as a dictionary of series, where the keys are the column names and values are the series that will form the columns of the data frame. Furthermore, all elements of each series are mapped according to an array of labels, called index. Alright, let's see in practically. Now we will know about how to defining a data frame. The most common way to create a new data frame is precisely to pass a dictionary object to the data frame constructor. This dictionary object contains a key for each column that we want to define, with an array of values for each of them. Let's see the example. Now you can see here we got a data frame from dictionary. If the object dictionary from which we want to create a data frame contains more data than we are interested, you can make a selection. In the constructor of the data frame, you can specify a sequence of columns, using the columns option. The columns will be created in the order of the sequence regardless of how they are contained within the object dictionary. As you can see here we got only two column object and price. Even for data frame objects, if the labels are not explicitly specified within the index array, Pandas automatically assigns a numeric sequence starting from 0. Instead, if you want to assign labels to the indexes of a data frame, you have to use the index option, assigning it an array containing the labels. As you can see here we got string index instead of numeric sequence. Now that we have introduced the two new options, index and columns, it is easy to imagine an alternative way to define a data frame. Instead of using a dictionary object, you can define within the constructor 3 arguments, in the following order: a data matrix, then an array containing the labels assigned to the index option, and finally an array containing the names of the columns assigned to the columns option. So as you can see here we got data frame using an alternative way instead of dictionary object. Now we will know about how to select elements. First, if we want to know the name of all the columns of a data frame, is sufficient to specify the columns attribute on the instance of the data frame object. Now you can see here we got columns index. Similarly, to get the list of indexes, you should specify the index attribute. As you can see the output. As regards the values contained within the data structure, you can get the entire set of data using the values attribute. Now you can see here we got the entire set of data used by values attribute. Or, if you are interested to select only the contents of a column, you can write the name of the column. Now you can see here we got all the data from price column. As you can see, the return value is a series object. Another way is to use the column name as an attribute of the instance of the data frame. Now you can see here we got same result as we before, in another way. Regarding the rows within a data frame, it is possible to use the eloc attribute with the index value of the row that you want to extract. Now you can see here we got the whole row value from index 2. As you can see here. The object returned is again a series, in which the names of the columns have become the label of the array index, whereas the values have become the data of series. To select multiple rows, you specify an array with the sequence of rows to insert. Now here you can see, here we got whole data from index 2 and 4. As you can see here. If you need to extract a portion of a data frame, selecting the lines that you want to extract, you can use the reference numbers of the indexes. In fact, you can consider a row as a portion of a data frame that has the index of the row as the source, in the next 0 value, and the line above the one we want as a second value, in the next one. Now you can see here we got whole data from first row, cos 0 to 1 is first row. If what you want to achieve is a single value within a data frame, first you have used the name of the column and then the index or the label of the row. Now you can see here we got paper from index 3 of object column. As you can see here, paper as index 3 of object columns. So that's why we got paper as output. So our selecting elements was up to this. Now we will know about how to assigning values. Once you understand how to access the various elements that make up a data frame, just follow the same logic to add or change the values in it. For example, you have already seen that within the data frame structure an array of indexes is specified by the index attribute, and the row containing the name of the columns is specified with the columns attribute. Well, you can also assign a label, using the name attribute, to these two substructures for identifying them. Now you can see here we got item as column name like rest of the column, and ID as the index name. Now we will set the column name as ID. Now see here ID as first column name. And now it's look like data table. One of the best features of the data structures of Pandas is their high flexibility. In fact, you can always intervene at any level to change the internal data structure. For example, a very common operation is to add a new column. You can do this by simply assigning a value to the instance of the data frame specifying a new column name. Now you can see here we got new as a new column. We can follow a similar approach if you want to update an entire column, for example, by using the function numpy_arrange to update the values of a column with a predetermined sequence. As you can see here. Now we will know about membership of a value. We have already seen the function is applied to the series to decide the membership of a set of values. Well, this feature is also applicable on data frame objects. As you can see here we got true as output from index 1 except rest of the elements. We get a data frame containing only Boolean values, where true has only the values that meet the membership. If you pass the value returned as a condition, then you'll get a new data frame containing only the values that satisfy the condition. Now you can see here we got exact value from index 1. Now we will know about how to delete a column. If you want to delete an entire column with all its contents, then use the del command. Now you can see here, the new column is deleted. Now we will know about how to filter data. Even for a data frame you can apply the filtering through the application of certain conditions. For example, if you want to get all the prices values smaller than a certain number, for example 1.2. Now you can see here we got only these rows which is less than 1.2. Now we will know about data frame from nested dictionary. A very common data structure used in Python is a nested dictionary, as the one represented as follows. As you can see here. This data structure, when it is passed directly as an argument to the data frame constructor, will be interpreted by pandas so as to consider external keys as column names and internal keys as labels for the indexes. During the interpretation of the nested structure, it is possible that not all fields find a successful match. Pandas will compensate for this inconsistency by adding the value nan values missing. Now we will know about transposition of a data frame. Transposition of a data frame, an operation that might be needed when dealing with tabular data structures, is the transposition, that is, the columns become rows and rows columns. Pandas allows you to do this in a very simple way. You can get the transpose of the data frame by adding the t attribute to its application. Now you can see here after transposed. Now we will know about the index objects. Now that you know what the series and the data frame are and how they are structured, you can certainly perceive the peculiarities of these data structures. Indeed, the majority of their excellent characteristics in the data analysis are due to the presence of an index object totally integrated within these data structures. The index objects are responsible for the labels on the axes and other metadata as the name of the axes. You have already seen as an array containing labels is converted into an index object, you need to specify the index option within the constructor. Now you can see here, the index objects. Unlike all other elements within Pandas data structures, series and data frame, the index objects are immutable objects. Once declared, these cannot be changed. This ensures their secure sharing between the various data structures. Each index object has a number of methods and properties especially useful when you need to know the values they contain. So now we will discuss about methods on index. There are some specific methods for indexes available to get some information about index from a data structure. For example, idmin and idmax are two functions that return, respectively, the index with the lowest value and more. Now see here, blue is the lowest value of the series. And white is the highest value of the series. As you can see. Now we will discuss about index with duplicate labels. So far, you have met all cases in which the indexes within a single data structure had the unique label. Although many functions require this condition to run, for the data structures of pandas this condition is not mandatory. Define by way of example, a series with some duplicate labels. Now you can see here we got duplicate labels. Regarding the selection of elements within a data structure, if in correspondence of the same label there are more values, you will get a series in place of a single element. As you can see here we got two white elements. The same logic applies to the data frame with duplicate indexes that will return the data frame. In the case of data structures with small size, it is easy to identify any duplicate indexes, but if the structure becomes gradually larger, this starts to become difficult. Just in this respect, Pandas provides you with the is unique attribute belonging to the index objects. This attribute will tell you if there are indexes with duplicate labels inside the structure data, both series and data frame. Now you can see here we got false, cause our index were duplicate, that means it's not unique. Now you can see here we got series as false and frame as true, cause inside the frame, there was no any duplicate. Now we will know about reindexing. It was previously stated that once declared within a data structure, the index object cannot be changed. This is true, but by executing a reindexing you can also overcome this problem. In fact, it is possible to obtain a new data structure from an existing one where indexing rules can be defined again. Now you can see here the reindexed. During this operation of reindexing, it is therefore possible to change the order of the sequence of indexes, delete some of them, or add new ones. In the case of a new label, Pandas add nan as corresponding value. Now you can see here we got 5 as nan, that means we didn't have 5 in our original series. As you can see from the value returned, the order of the labels has been completely rearranged. The value corresponding to the label 2 has been dropped and a new label 5 is present in the series. However, to measure the reindexing, the definition of the list of all the labels can be awkward, especially for a large data frame. So you could use some method that allows you to fill or interpolate values automatically. To better understand the functioning of this mode of automatic reindexing, define the following series. Now you can see the index. As you can see in this example, the index column is not a perfect sequence of numbers. In fact, there are some missing values, 1, 2, and 4. A common need would be to perform an interpolation in order to obtain the complete sequence of numbers. To achieve this, you will use the reindexing with the method option set to fill. Moreover, you need to set a range of values for indexes. In this case, for specifying a set of values between 0 and 5, you can use range 6 as argument. As you can see the ffill method. As you can see from the result, the indexes that were not present in the original series were added. By interpolation, those with the lowest index in the original series have been assigned as values. In fact, the indexes 1 and 2 have the value 1 which belongs to index 0. If you want this index value to be assigned during the interpolation, you have to use the bfill method. Now you can see the bfill method. In this case, the value assigned to the indexes 1 and 2 is the value 5, which belongs to index 3. Extending the concepts of reindexing with series to the data frame, you can have a rearrangement not only for indexes, rows, but also with regard to the columns, or even both. As previously mentioned, the addition of a new column or index is possible, but being missing values in the original data structure, pandas add nan values to them. Now you can see the new column, which is same to colors. So friends, our today's data frame part 1 was up to this. Thanks for watching the video. See you in the next video. Please subscribe our channel and don't forget to like and share the video. Thank you.